I've been working on e-democracy in the last 9 years, and the more I work on this, the more I went onward, the more I started to understand the big picture and work less on the tiny details that I still did, but really try to understand where is this going for and why this is important. And this is the talk that I'm going to give. So it's going to give about the vision and not so much about the little details. And I kind of understood that this is the right audience for that, so that's why I'm doing this. Now, you know that right now, you probably, unless you are living under a rock, you know that there's a big discussion right now about artificial intelligence and natural intelligence, and where this is actually leading through. And I'm not going to describe natural intelligence. I mean, you all have it. We are going to describe a little bit artificial intelligence, and there are things that with artificial intelligence we are able to do right now, and there are things that not yet, but we are rapidly becoming able to do it. So we have a robot, a very specific robot. We have task-specific artificial intelligence, navigation system, chess, this kind of thing. But what's really missing is autonomy, is task independence. When you have a Siri and you ask him a question, that's starting to go in that direction. But you know how much programming is going on behind that, so that you can just say something and it answers to you. Basically, it only works because millions of people are using the same program and asking the same questions. And there have to be a talk about the fact that this whole thing is growing and is based upon CPU growth, and this CPU growth is growing exponentially, and there really is basically we haven't seen it not just stopping but even slowing down. In fact, it has actually increased in speed recently thanks to Bitcoin. So basically this continuous increase in speed in CPU power is making a lot of people believe that eventually robot will actually be as intelligent as human being. Okay, I think all of you have heard about this, and if you haven't, well, this is a big news. But so exponential growth will lead to robot probably being as intelligent as human being. But when you have this, now you actually start to have a problem with autonomy and with ethics, because will those robots share our ethics or not? Are we going to have some sort of Terminator coming out at some point or not? And there have been three main, there's been a lot of people discussing this. I'll cite three. The first one that spoke about it was Asimov with the three laws of robotics, which I hope all of you remember, and they are: number one, each robot should always each robot should always avoid to harm another human being or act in such a way that because of his lack of action, another human being might get harmed. Number two, a robot will have to do what a human being wants unless this goes against number one. Number three, a robot must maintain its own self-sufficiency, self-maintenance, unless this goes against number two or number one. And if you read Isaac Asimov novels, you know how if you just tweak a little bit those laws, you get into big troubles. And then you have Kurzweil, who really is the guy who worked a lot on this and says that by 2045, robots will have surpassed human intelligence. And then you have Hawking, and Hawking actually said that actually there is a very big risk. There is a risk that this might terminate the human race. Now, so we have artificial intelligence and natural intelligence, but there is another player inside of which very few people speak about it, and that is enhanced intelligence. Enhanced intelligence is actually what you get when you take a human being and you give him enhanced power thanks to computer, artificial intelligence on the side, and so on. So all of you is an enhanced intelligent person every time you are connected to the internet. This is why when you don't have Wi-Fi, you feel like a part of you is missing, because a part of you is actually missing. If you are a driver and you have a navigation system, you are much more than a normal driver. You can go to another country, another city, just go directly to a particular place, and then come back and return. And same things with a doctor and medical expert system, and same things with chess player. This is actually quite interesting. You know that Deep Blue have won over what is it, Karpov or Kasparov? I don't remember. And yes, now we have a chess computer that are able to beat a world champion. But now a new sport is coming out where you have two chess players, and each of them has their own computer on the side. And the computer suggests the moves, but the chess player decides what to do. And then so it becomes some sort of a suggestion system. And a chess master plus a computer system is stronger than a chess master. Surprise, surprise. So this was enhanced intelligence. And now I'm going to tell you about something else. Another form of intelligence that you don't know about it, which I called merged intelligence. Now, what is merged intelligence? Is many human beings integrated through technology. And as I'm going to speak about it, you will find more and more examples of this. So, the first clear example where this was really, really clear as a difference from anything we have seen were wiki. The moment in which Wikipedia came out, suddenly we had a situation where everybody just giving a little bit of work and a little bit of participation ended up in a huge project coming out. But if you think about wiki, in a sense, wiki is not so different from science or culture. So in a sense, the first basic merged intelligence that we have is culture, because with people speaking to each other, they refine the knowledge, and slowly it gets passed on and it changes. But then another form could be voting. When people vote, they put together their intelligence. In a sense, it's very simple, it's very basic. But if you have voting, then you can say that democracy is a merged intelligence. And in the moment in which you have this, well, now you have anonymous. You know, the people that vote online to decide what to do. Who is the intelligence over there? None of them, not a single person is. It's the collective who becomes. And of course, over there you also have edge riders, for example, that made this project of writing a report in a collective way. And then, of course, the World Wide Web. Notice, I have not spoken about the Internet. I've spoken about the World Wide Web, which sits upon the Internet and is the collection of the web pages. But they are very different one from the other. And by the way, those are not they are not ordered in time. This is actually the order in which they kind of came out. Although I'm not really sure between Anonymous and Wiki which one was first. Wikis were first. Okay.
Mid-90s.
So now the big question is, how do those systems take decisions? Natural system, natural intelligence system, they take decisions. You know, all of you take decisions, and however you do it, that works, because you managed to arrive here and that was a decision. Artificial intelligence, well, we have a difficulty over there, and that's why we are trying to build a robot that has autonomy, and that's why we have an ethical problem and so on. So we have an issue here. Enhanced intelligence is basically sitting upon natural intelligence. Is often one person plus something, and the decision is taken by the person. So this one is using up this one. But what about merged system? What about merged intelligence? How does those systems take decisions? Now, of the system that we've spoken about, 3 of them take decisions and are connected to taking decision: voting, democracy, and the anonymous system. Actually, there are other decisions inside. I mean, in a wiki, you have a decision all the time. Will we write this? Shall we write this other? And so on. If you really have looked into those, you see that it's like something is missing. And by saying something is missing, I say, when you are voting, you just vote yes or no. When you have a wiki, you show a complex picture. We don't have a decision system where people merge their partial understanding so that at the end you end up with a complex understanding and a final decision that integrates all those various bits and pieces of understanding. And this is what I'm actually working on. Now, there are 3 examples of situations that have tried to do this. One of them has been e-democracy. E-democracy came out from the internet on one side and from voting theory on the other. And if you know something about voting theory, which is about how people vote, you know that voting theory is based upon closed questions. Which of those candidates do you want to have? The candidates are already there. You just can vote yes or no, or you can make a list, or you can choose one, whatever. But it's a closed question, and in e-democracy, you actually start to have open questions, because now all of you becomes not just a yes or no, but a source of intelligence. We actually want your brain and your ideas and your point of view to become part. You might actually have the next genius idea, and we want that idea to become part of it. So in e-democracy, often you have systems where people can insert new ideas, and the problem is how to make it fair respect to ideas that are there before and ideas that are there later. Now, just show of hand, how many of you actually here know sociocracy?
No.
Sociocracy. One.
When you say know it, like vaguely understand it or practice it?
Vaguely understand it. Yeah. So 5 people up to now, and everybody else after this talk. Okay. So sociocracy has about maybe have even 100 years of history on the back, but actually it really changed when it got translated from Dutch into English, which happened in 2005, and now it's becoming, it's really exploding. The main difference, it's a democratic system, but the main difference is that it's not consensus-based, but is not based on voting, but is based on consent. So instead of saying who wants this to happen, says who has a problem with this from happening. And all the people who are neutral about it, in a consent-based system, will. Can you hear me? All the people that are neutral about it in a consent-based system are actually supporting it by default, whereas in a consensus-based system, people need all to want it, and it's much harder. Okay, there is much more inside sociocracy. It's a wonderful system, and it's a minimum technology system, so you can use it without. And then there is this system that some crazy mathematicians have been working on in the last 8 or 7 years, and it's basically a human-based genetic algorithm facilitated by an artificial intelligence. I see Vinay is particularly amused by this because he has already.
He's also very tall and very handsome.
It is. Who, Vinay? So, the mathematician is tall, yes. So this is the basic structure of Vilfredo. And the basic structure of Vilfredo works like this. There is a question, and then everybody writes their own answer to this question. Then there is a voting period where everybody votes, and in the basic system, people just vote yes or no. And then they also can say why yes or why no. And then there is a filter. and the filter will take away some of those elements and keep the others. So some of these, if you found a system that has reached a proposal that has reached consensus, you keep that one and you've reached consensus. If not, you write new proposals and you continue. And you write those new proposals on the base of the one that made it to the next generation. Now, I'm not going to enter into the mathematics of this. I have gave this presentation several times, and it would really make this talk about 1 hour longer. So it does not matter right now. You have to trust me that this system exists, and it does not work. It's not based upon how many votes a proposal reaches. It's based upon who are the people that votes a proposal. Not as what have you done in the past, if you have a degree or not, but which sets of people votes a particular proposal respect to another proposal. So it compares sets of people, and it's a purely mathematical system. Okay? So this was the basic system.
One more thing you should say about it.
Yes?
Is that it structurally evolves towards consensus.
Yes.
So it takes disagreement, gradually produces proposals that more and more people agree on. So you use it for drafting law rather than proposing law.
Yes. So let me repeat what Vinay said, because it was not captured. That's very important. Because of the way it works by selecting and filtering some proposal instead of others, basically it's bringing out some proposals that are representatives of the whole community. And then it asks everybody to write new proposals. And in this process of filtering and writing, it gradually builds a consensus based upon the various proposals. Okay, and this is very, very important. It works for how questions. How should we do this? It doesn't work so much on what questions. What shall we do? This is a program. Which of those talks shall we have or not? It wouldn't work for that. But how shall we organize the next unMonastery? This would be, for example, a perfect question for that. So basically, then we started developing an artificial intelligence in the middle of this. And the artificial intelligence, by analyzing how people have voted, will find in what cases one person was particularly important for the success of a particular proposal. Suppose that there is a proposal that would pass, except that Vinay voted against it. So at this point we can go and ask Vinay what's wrong with that particular proposal. Now, this is only one example. The system analyzes the whole vote of everybody, and on the basis of the whole vote, goes and finds out who are the people that we have to speak with, and who should be the person that speak to what person and ask what question. So basically, the system works as a moderator, and it's an artificial intelligence moderator. Because it's a moderator, and because it's a computer system, it's not bound to only speak to one person at a time, so it can grow to more than, normally a moderator can only work to about 10 people, because after he goes crazy and it really becomes difficult to get people to work. We are trying to go up to 20. It's not a lot, but 20 people, everybody really participating, that you have doubled the size of all the committees around the world. That's quite something. So there are various elements in this artificial intelligence system. I'm not going to enter into them. There are cycles, there are particular questions, and I'm just going. Let's just go on. Then we took all the lessons that we got from this system and built a second system. And the second system had various changes, and one of them was that voting was not anymore yes or no, but was in a triangle. Now, this is the most difficult thing that people will have to understand if they want to use this system. But once this is understood, everything else will be very easy, because generally the system in every moment will ask you what to do. Please do this, please evaluate this proposal, please try to merge those two proposals, please explain this proposal to this other person, and so on. So those are always a very simple thing. This is the only thing which is going to be a little bit difficult at the beginning. We're going to make a video to explain. But basically, the higher it is, the more you understand a proposal, the more it's on the right, the more you agree with that, the more it's on the left, the more you disagree. If you don't understand at all a proposal, you cannot neither agree nor disagree with that. And the fact that it's continuous gives me enough information that from a mathematical point of view, I can do a lot of little tricks to make sure that the system converges to a consensus much more rapidly and for more people and so on. I'm not going to enter into that, just believe me for this. But basically, for example, we can find which proposals are badly written but contain really good ideas, and find out which people are really good at writing and explaining proposals, and ask them to rewrite those proposals. This is something that you can do with this kind of tool, and that you could not do if people are just voting yes or no. Okay? And so, right now, Vilfredo 2.0 just went online. It went online on Tuesday. We are still working through the various bugs. It's at vilfredo.org. And basically, it has only one generation, the new one. We haven't yet completed the circle. So people can ask a question, can propose answer. Now, notice one difference that it's not written over here. In the old version, everybody could participate in every question. And the result was that people would come in, go away, not participate, and basically it would not really focus. Now we ask whoever writes a question to invite the people who should participate into that question. The difference is enormous, because now you don't have people coming in halfway and then not knowing what was discussed about. It's now a tool for a community or from a group. It's not a tool in general. It's more like, what's the tool for deciding a time where to have a meeting? Doodle. It's like Doodle in a sense. You open a Doodle to decide a time, you open a Vilfredo to decide the answer to a how question. Something just like that. There is this triangle, and there still is the same kind of filter, although we had to redo all the mathematics for this because let's just say that with the new voting system, the domination between the proposal are not transitive anymore. Mathematical blurb to say that it's really, really much more complicated, the mathematics that is behind. So, that's the reason why it took me more than 1.5 years to actually do this particular step. But now it's out there.
The triangular voting stuff is absolutely amazing.
Can you give a specific example of a question gets posed and then basically go into the system and it speaks?
I can on the old Vilfredo, not on the new one.
Can you?
Yes, sure. We asked at some point, a question about Vilfredo itself. And the question was, how should we handle the wall of text problem? And the wall of text problem is, what do you have when people write a huge chunk of text and nobody reads it, because it's so big that nobody actually can read it. And because of this is a decision system, people don't actually take decision, they don't vote, and as a result, the whole system halts. So we had maybe about 10 people on and off participating in 4 generations, and people suggested from writing an abstract to making cost, to putting points, to listing and so on, and it went through various generations. If I have the time, I'll open just something where you can see actually the graph of this going through it. But basically, after 4 generations, we found a really nice proposal, which was write the summary. The summary should be not more than so many characters. The real proposal can be as long as you want, but if it's longer than so much, it must have a summary, and then they also should order by, and so on. So that was an example. The other thing is, because of the triangle, we now know if different proposals are in the Pareto front, so different proposals pass the filter, we now know which proposals the community prefer respect to the others. So if we want to stop a question halfway, we can do it, and people will just, and we will know, okay, this one, among the one that were filtered, this one is the one most liked. Okay, so we don't need a second voting at this thing. And this was a second problem that we had. In the old Vilfredo, there was no halting mechanism. So basically, sometimes people kept on discussing for weeks on end, and eventually one person would remain there just voting their own proposal, and he would have won just by lack of patience of everybody else and so on. But that means nothing. Now you decide at the beginning how many generations this is going to last, and then once it has finished, that's it. Whatever result is the result. People can try to extend it. If everybody agrees, it gets extended, but if not, that's where it actually stops. So those are the differences. Yes, no vote, open to anyone, open to groups is actually much better, open to groups, unlimited time, finite number of generations. There used to be, this was the artificial intelligence. We are going to get an expert system as a moderator over there. It used to work only on a how question. We are going to have different strategies of using those tools to handle different kind of questions. So if you have a what question, you don't want the generation, but you want the triangle. Whereas if you have a question where you only have images, you don't want the triangle because it makes no sense that you have not understood an image. You just want a yes, no, and so on. The old one was one code, and it was one spaghetti monster code. This one is back-end, front-end division, API, and so on, and it should be able to work well for sociocratic groups, and it should work well also on tablet. So people around the table can discuss while they're actually voting, and they're actually using it. And the conclusion of all this is that merged intelligence is coming. This is only one example. There's also sociocracy, there are edge riders, there's a lot of other ways where people are merging their intelligence. Resistance is futile. You don't have to be scared. I mean, it's useless. Especially you don't have to be scared because it will have our ethics. The difference respected to...
That's why I'm scared.
Vilfredo can be one of those mixed intelligence systems, and we need your help. We need your help in testing it, in using it, in speaking around about it, and coding it and designing it. We need a lot of help, especially from user interface people and user experience people. We need a lot of help. And that's it. Thank you very much.